My dear students, welcome back to the physics class. We were dealing with the second chapter, motion. The first part already we have completed. There we have discussed about rest and motion. What is rest and what is motion? And there we also, the last class, previous class, we have seen about different types of motion. Different types of motion. Today, we are going to discuss about uniform motion, non-uniform motion, followed by distance and displacement, then scalar and vector quantities, and finally speed. So these are the topics that we are going to cover today. Now, uniform and non-uniform motion. So first we are going to discuss today is uniform and non-uniform motion. Uniform motion means if an object is under motion, if it is covering equal distances in equal interval of time, then we can say that the object is at uniform motion. So what is uniform motion? If the object is under motion and that object is covers equal distance in equal interval of time, then we can say that the object is under uniform motion. For example, if a car is running, every 1 minute if it is covering 500 meters, first minute it is covering 500 meters, second minute also it covers 500 meters, third minute also it covers 500 meters. So every 1 minute it is covering 500 meters. So equal distance is covering in equal interval of time. So we can say that body is under uniform motion. That body is under uniform motion. Now, the second one is non-uniform motion. If uniform motion, equal distances are covering in equal interval of time, what will be the non-uniform motion? Non-uniform motion means unequal distances are going to cover in equal interval of time. It covers unequal distances in equal interval of time. For example, first 1 minute or first 1 minute, how many kilometers are running? Maybe 200 meters are running. Then second minute 500 meters are running, and third minute maybe 400 meters are running. So distance, unequal distances are going to be covered in equal interval of time. That is called the non-uniform motion. I hope you understood both terms, uniform motion and non-uniform motion. Now, the second topic of today is distance and displacement. Distance and displacement. Suppose here I am going to consider 3 points A, B and C. A, B and C. Suppose one person is going to travel from A to B, then he is going to B to C. Okay, B to C. And one person is directly going to from A to C. From A to C. Distance is the total length covered by an object is called distance. Distance traveled by a moving body is the actual length covered it. Distance traveled by a body is the actual length covered it. What is the actual length covered it? This is the from A to B, then here. So this is called distance. This is called distance. Now, what will be the displacement? Displacement of the body is defined as the shortest possible distance. Displacement is the shortest possible distance covered by the object. That means this is the shortest possible distance. This A to C, this is called displacement. This is called displacement. Distance is the actual length traveled by a body, whereas displacement is the shortest possible length traveled by the body. Now, from the initial position to the final position. Again, one more example. This is initial position A, this is the final position B. I want to travel. I can travel like this. like this a person is traveling, or like this a person is traveling. In these both cases, it is distance. That means they are going to cover the total distance traveled. But what will be the shortest distance? Will be this one. This is the shortest distance, and this is called displacement. This is called displacement. Displacement is the shortest possible distance from initial position to the final position, whereas distance is the total length traveled by that object. I hope you understood. Then, next topic that we are going to cover today is scalar and vector quantities. Scalar and vector quantities. Third point we are going to cover is scalar and vector quantities. What is scalar quantity? A physical quantity which is expressed only in magnitude. A physical quantity which is expressed only in magnitude is known as scalar quantity. There will not be any unit, only magnitude. Okay, for example, distance is the example of a scalar quantity because only the magnitude is equal to, it is prepared to cover. Distance is a scalar quantity. That means we will not have any other quantity, only 10 meter. That means only 10 we are quantity, only magnitude we are telling. Then time, temperature, mass, speed, density, area, volume, work and energy are some other scalar quantities. All this time, temperature, mass, speed. Here always we are just measuring only what magnitude. Okay. Now second one, what is vector quantity? Vector quantity, a physical quantity that in order to express that physical quantity, we need both magnitude and direction. Both magnitude and direction to be described is called a vector quantity. For example, displacement is an example of vector quantity. Displacement is an example of vector quantity. That means we are just expressing the direction from where to where it goes. We can say that here maybe 10 meter towards east. I can say which direction is going from initial to final. Okay, then next one. Both some other examples of vector quantities are velocity, acceleration, force, and weight. When we are expressing force, we will consider the direction of force applied, or the acceleration. Then velocity, weight of an object, we will consider the direction also. So, what is scalar quantity? A physical quantity that is expressed only in magnitude is called a scalar quantity, and a physical quantity which is expressed by using both magnitude and direction is called a vector quantity. For example, a car is traveling 10 km. It is a scalar quantity. If I am telling that a car is traveling 10 km towards east, magnitude plus east towards east is the direction, then that will become vector quantity. Clear now? That will become vector quantity. Now, the third one is speed. We are going to consider about speed. What is speed? Speed is defined as distance travelled by an object in a unit time. Distance travelled by an object in unit time is called speed. Distance travelled by an object in unit time. How we will find out speed? Speed will be equal to distance divided by time. Speed will be equal to distance divided by time. Distance will be in meter. The SI unit of distance is in meter and time is in second. So what will be the SI unit of speed? SI unit of speed will be meter per second. Meter per second is the SI unit of speed, and we know that multiple speed will be used, and that name we will use kilometer per hour. Kilometer per hour is a multiple of SI unit of speed. SI unit of speed is meter per second. You have to keep it in mind. Now, next one is speed of an object do not require. That means speed. When we are speaking about speed, we will not be expressing direction. We can say that speed of the car is 10 km per hour or 50 km per hour. Only the magnitude we are expressing. So speed is a scalar quantity. Speed is a scalar quantity. If along with that a car is running 50 km per hour towards east, then that one will become vector quantity. But when we are expressing speed, we used to express only in magnitude. So speed is a scalar quantity. Now, uniform speed. Along the speed, already we know that one is uniform motion. Then what will be the uniform speed? If the object is covering equal distance in equal interval of time, say, then it is known as uniform speed. For example, if an ant is moving in 1 second, in 1 centimeter, second also 1 centimeter, then we can say that the ant is having a uniform speed. Then what will be the non-uniform speed? What will be the non-uniform speed? Non-uniform speed is the unequal distance traveling in equal interval of time. That means maybe the first one a distance of 1 centimeter in 1 second, and second one 1.5 centimeter in 1 second, maybe third one 2 centimeter in 1 second. Unequal distances is covered by equal interval of time. Then that is called the non-uniform speed. Non-uniform speed. One more topic regarding speed. What is average speed? What is average speed? Average speed is normally considered with the respect when we are having a non-uniform speed. If it is a uniform speed, that is equal to average speed. Then, if it is a non-uniform speed, then how we are going to calculate? For example, in 1 minute or 10 seconds, it is going to move 10 centimeter. Next 10 seconds, it is going to make a 20 centimeter. Then what will be the average speed? First one is 10 centimeter, second one is 20. So 10 plus 20, that is the total distance traveled, 30. 30 centimeter is the total distance traveled. Maybe total time taken is 20. So 30 by 20, you are going to get a average speed. So how we are going to calculate average speed? Average speed is the total distance traveled divided by total time taken. Average speed is the total distance traveled by an object divided by total time taken to cover that distance. Some examples are given in the textbook. Calculate the speed of an object if it covers a distance of 15 meter in 5 seconds. So total distance is 15 meter in how many seconds? 3 seconds. So what will be the answer? 5 meter will be the average speed. Average speed will be equal to 15 by 3, 5 meter per second. 5 meter per second. Now, this is about today's class. So, whatever things we have discussed today, we have discussed about the uniform motion and non-uniform motion. If the moving body covers equal distance in equal interval of time, it is uniform motion. Unequal distance in equal interval of time, then it is non-uniform motion. The distance and displacement. Distance is the maximum length covered by an object is called distance, whereas displacement is the shortest possible distance between the initial point and the final point. Then we have seen about the scalar quantities and vector quantities. Scalar quantities are the quantities which are expressing only in magnitude, whereas vector quantities will be having both magnitude and direction will be there. Then finally we have seen about speed. Speed is the distance traveled by unit time. Distance divided by time, you will get the speed. SI unit is meter per second. Then there will be uniform speed will be there, non-uniform speed will be there. Uniform speed is equal distance will be traveled in equal interval of time. Non-uniform speed, unequal distance is traveling in same interval of time. At that time, we are able to find out the average speed, total distance traveled divided by total time taken. You will be getting the average speed. So what you have to do? You have to read this topic, what we have covered today. Maybe all these topics you can read 3-4 times from the textbook, and you have to go through the study questions. You have to find out the answers, all the answers which is related to this topic by your own. And if there is any doubt when you are finding out the searching the answers in the textbook, you can contact me. I will be available on the WhatsApp always. Okay, so do this work in your copy. Thank you.